Right, guys. Yeah. Good morning. So, in last session, what we have seen, different cloud offerings, right? And I say different cloud offerings. And so on. Right? That is what we discussed briefly. And in today's session, what we will do, let's understand before we go ahead and talk about AWS, let's try to understand how our day-to-day things or how day-to-day operations looks like in the traditional on-premise environment, right? So for that, what I'll do is I'll take a small example. So it will be, let's consider this will be your networking basics related to on-premise. Okay. So let's consider a small example of your home lab setup, home internet setup. Okay? What you'll have, you'll have a Wi-Fi router, right? And that will be connected to one of your internet service provider. ISP, right? And then inside you'll have laptop, let's say desktop, and so on. You have a couple of devices like this. Right? So all these devices are connected to this Wi-Fi router, right, with some IP address. Let me see what is my IP address. It is 102. And what is my Wi-Fi router IP? Right. And what is my actual IP address when I'm sending a data to internet? I'll simply go here. What is my IP address? This is my IP address over the internet. Okay. So I just want to understand what is the difference between these two IP ranges. You have any idea, Sharon?
No, I don't have.
Okay. So when I talk about networking basics, irrespective whether it is on-premise, a cloud, or anything, you'll have two types of IP addresses that are available in the market or that are available for global usage, which is IPv4 and IPv6. So IPv6 is not in our discussion point here. So majorly, if you see, majority of your infrastructure will be managed through your IPv4 setup, right? Which is an 32-bit IP addressing. Okay. Now, this 32-bit IP addressing is divided into 4 octets. This is the starting to ending. That's the end. Right? Each octet will be 8 bits. Okay? And I'm not going to very ground level basics for the networking, but just for our understanding how this networking works in AWS. So we'll try to grab some of these basics today. So now what they have done, whoever has defined this back in 80s or 90s, right? They have divided all these IP address, 32-bit IP addresses into multiple classes, okay? Namely class A, class B, class C, and so on. So what is this class A? What it talks about? Let's say your class A IP addresses starts from, give me a second. I hope I'm still audible.
Yeah, you're audible.
Okay. So the class A IP addresses starts from 2 to 126.255.255.255. Right. And then class B starts from 128 to 191, 255, 255, 250. That is how they divided. And 192 to, I believe it's 223. Right. Let's see. Two 23. Right. Now, after that, class D and class E are there. Okay, they are more of reserved for their internal usage. Whoever has defined this, it is kept with them, D and E, for their internal usage and future usage, I would say. Now, whoever is running an organization, whoever is running a small or I'll say grocery shop or a small scale industry or a small IT firm or anything, or your home appliances like this setup, they have to use one of the IP range from this A, B, or C. Now, what they have done, they have segregated each class into 2 sections again. Okay, so there's 2 sections, technically what we call it as public IP and private IP. Same thing, what you call it as technically routable and a non-routable IPs. What is the difference here? Right? So if I want to map with this existing setup, what we have seen, this is routable IP. Okay, and this is non-routable IP. Means what? IPs which you are able to reach out to them over the internet, they call it as routable IPs. IPs which you are not able to reach out to them over the internet, then you call it as non-routable IPs. So non-routable IPs are private IPs. Routable IPs are your public IPs. Now, from where they have derived, they don't have any other segregation. they have derived all these things from all these three classes only. Okay, so how they divided? Let's see. In the class A, 10.0.0.02, 10.255.255.255, which is private. What about the public? Public is 9.255, 255, 255, 11.02, 126. Right. So consolidately, these two we call it as public. Make sense? Any example for public IP? See, you're getting a response, right? When you ping the IP at ping the yahoo.com, you're getting a response from 98 series. So this 98 series will fall under class A because 0 to 126 is class A, and it is not falling under 10 series. It is not starting with 10 because it is not private. It is more of a public IP address. So this is the IP we refer to this is the IP we refer to right class A. Give me a second. Yeah, this is IP we refer to class A public IP, right? Because this is reachable over the internet. Right now, back to your discussion where you will use this private range. We will use this private range in enterprise organizations. Okay? So if you are working for any organization, you will see all those organization user laptops, desktops, and servers, and cloud equipment, cloud servers, and everything will run on 10 dot service. Okay, so now moving on to second class B. Again, they divided into private and public. So 172.16.0.02, 172.31.255.255, you become your private will be used at mid and large scale. Will be used at mid and large scale organizations. One second. Fine, let's leave it rather than playing with that. Now, if I want to use the public, then what's the public? 128.0.0.0 to 172.15.0, sorry, 255 and 172.32.0.02 120, sorry, 191, 255, 255, 255. Right. This we consolidately call it as public. Make sense? So what is the example for your public? (142) series. Right. So 142 series IP, which is in class B, not under private, then it's public. That is the reason you are able to access it over the internet as well. Make sense? Similarly, class C. Class C again divided into two classes. Your 192.168.002, 192.168.255.255, which is private, home, or say small office usage. And then what is the public range? 192.0.0.0 to 192.167 to 55 to 55. After that, 192.169.00 to 223 to 55 to 55 to. This we call it as public. Consolidately both, we call it as public. Any example? Spring, I believe GoDaddy. GoDaddy.com is hosted on 208. 208 is your class B, sorry, class C range, not a private range. Obviously, it's accessible over the internet, is your public range. Understood? Any questions on this so far? Shane. Good.
No questions, Raj.
Right.
So
Now,
the Wi-Fi router, it will be like what
I'll
public?
come back to this point. Okay. So this, if this range is clear, and then
Yeah, this.
we'll talk about subnetting and all, and then we'll come back to here.
Okay.
Okay. Now, when I talk about private and public IPs, private IPs can be managed internally by end customers. When I say end customers, if I take home Wi-Fi, okay, every user can set their own range of class A or sorry, class C private IP. Getting my point? And if I consider small or mid-range office, network engineer can configure class B or a C private IPs in office switch. And when it comes to a large or enterprise, range organization, network architect will plan for private IPs considering, right, number of locations and data centers and remote offices and so on. And your network engineer will help in deploying. Make sense? Now here we'll use class A or B or C, all the three private ranges. Where exactly you will use? In your home, small office or enterprise grade organizations, anywhere. Now, when it comes to public IPs cannot be managed by individuals. Okay, one thing is clear, right? So first thing, you need to buy them from ISP, which is Internet Service Provider. Okay. Organizations may buy them in bulk. Clear? In short, if I consider this my home lab setup, let's look at this point. Home Wi-Fi, every user can set their own range. For my home, I'm the one who can set the range. How to? I'll simply go here and access 192.168.1.1. You'll get this TP-Link Wi-Fi router. I might forget the password, right? Yeah. I might need to check this later on, but I can log in into my switch and I can change the range. If I don't want this range, I can change the another range. This is at a home lab level. Small and medium office ranges, I do have a switch at my home for small medium offices. Consider myself as a network engineer, right? I can go to VLAN management and VLAN settings. I can define a VLAN. So what is VLAN, what is subnet and all I will explain in a few minutes. I can go to IP settings and I can define my own range. If I don't want to use this range, I can add my own range. 10.2.0.0 and apply. Right? This I can do it. This is in my control. Right? So small and mid range, network engineer can configure either A or B or C for a small office and stuff. For large, you need a planning and stuff at the larger scale that is done by architect, and you are helping them in configuring whatever the ranges that he suggests. Now, in my home setup, Wi-Fi router is configured with this, and all the inside the building, all the communication, what I call it as private range or a private IP communication. The moment if your data is leaving this building, okay, it is leaving the building and it is going to the internet, then it will ask for IP address, which is unique identification of your home in the internet. So this public IP is allocated to you so that if you are sending data to internet, let's say you're sending data to Facebook, sending data to YouTube, sending data to Insta, and so on. When they are sending a response back, to whom they will send over the internet? To this address. Okay, then you will receive the response from these respective sites, and your Wi-Fi router will receive the traffic via this IP till here, and it will convert as a private range and share with the all the devices which are running inside the home. Make sense? Any questions on this?
Now it's clear.
Now, if I take the small office, Another example is, if I take the small office has, let's say, front end reception and all, and then it has left wing, right wing, right, and so on. Now you have people coming into office and working on a day-to-day. Now on the back end, let's say I have a VPN device, or let's say securities device, or VPN device I will call it as, okay, which is installed in my home lab. I'm using Wi-Fi router to access the connection from the internet, right? Here I will use the VPN to access the connection from the internet. So from where I'll get ISP. Who is that ISP? In our case, let's say, which is Geo, just an example, for one of the office. And same Geo gave me the internet connection as well. And I do have another ISP, which is Airtel. I will also ask them to give a connection. I'll connect two cables. Two cables, they'll connect on the same device. Now, because it is my home, I have 5 or 6 devices. That's it. But when it comes to office, I have, let's say, roughly around 1500 people working every day. Okay, 1500 people working every day in entire office. Now, if in your home, if Wi-Fi router or an internet is down for 2 minutes, it's fine. You'll be able to manage your stuff within the home. Or more, or max to max, what you will do, you'll call that ISP and then you'll shout at them. Right? But when it comes to office, you can't take a risk, right? You have 1500 people working. If a connectivity is lost for some time, that means whatever the operations, whatever the delivery that they are doing from this office will be stopped for that particular duration. It can be 1 hour, 1 minute, or 2 hours, whatever the time frame. Now, in order to avoid that, I'm taking two connections. When I'm taking a two connections, both of them will give a range of public IPs. Let's say for my internet, home internet, they gave me one IP. If I take the dedicated link, let's say they give 10 public IPs. Geo gave me 10 public IPs. And Airtel also gave me 10 public IPs. That is along with my plan. Let's say yearly 30 lakhs for internet. So I'll get 10 IPs for free. And on the other side also I'll get 10 IPs for free. Now inside, this is connected to Wi-Fi router. Sorry, this is connected to VPN device. How inside the communication will happen? Let's say I have what I have is cabinets, or let's say cabinets connected like this. You have people working just an hypothetical example. Desktops. Now what you will do from all these things, you will do one thing. You will keep one switch here, Yeah, just bear with me. You'll keep one switch here. What is a switch? Your network switch, which is internally connected with, let me delete this, which is internally connected with your VPN device. From this switch, all these cabinets are connected. From here, it is connected to the switch. Like this. Okay. Now, on the left hand side, this is VIP. I'll say your senior management team who sits here, and then your HR, your local IT support, right? On the right hand side, you'll have developers, and you'll have your DevOps team sitting, or your PMO, project management team sitting, right? That is how this has been assigned. Now, in this case, how I will arrange the IPs, even for a reception, I have a couple of people sitting in a reception here, 3 people or sitting in reception, and you'll have digital flyers rolling out on the TVs, and you'll have security cameras at the entrance and every corner of your office. Make sense? Now, how you will give the IP ranges to this? Now, do you think 1500 people will suffice with the class C? Let's understand how many IPs that your class C will give you. So class C starts with 192. I'm talking about private only. That's the whole range, if you observe. Right. So from this range, how the IPs works: 192, 168, 0.0, and then after that 1, 2, 3, and so on. What is the last? 255. I'm talking about, please recollect, I'm talking about the last update, 4th digit. Okay. Now, how many IPs that you got total? How many IPs that you got total? 256. Correct? 0 to 255, that has become 256. Now, in a network terminology or in a network basics, you can't use all the 256. You can use only 254. You can use only 254 IPs. Okay, where 0 and the last IP 255 can't be used. Why? Because 0, let's say your subnet, 0 is, or 255 is, one is your subnet mask, another one is your broadcast IP. These two IPs we can't use it. Fine. Now, from a office perspective, let's see if we are able to use this one. Yes, we are able to use this one, but I have decided that I'm not going to use class C. I want to use class B. I'll tell you the reason. Right now, how this let's move on. How this IP is further divided. Once that is done, let me reduce the size a little bit. And 192, 168, 1.0, 1, 2, 3, and so on again 255. Total again you'll get total 256, usable 254. 192, 168, 2.0, 255. Again same story, 256. And so on till what time? 192, 168, 255.0, 1, 2, 3, and so on, 255, which is again 256 IPs usable 254. In short, total equal to 255 into 255. Am I correct? $65,000. Okay, sorry, my bad. It's 256 into 256. That's the total IPs, right? Total 256 IPs. So 65,535 IPs. So 36 IPs you will get in class C. Understood? Similarly, class B, how many IPs you will get? Class B starts from 172.16.00 to 172.31.255.255. Okay, so if I consider this one, the first octet, see, if I consider this one, you will get 256, and if I consider second octet, how many? Again you'll get 256. Now the difference between these two, how much? 16, 17, 18, 19, 20, right? And 31. 11 plus 5. How much? 11 plus 5. I think the difference between here is 16. Now, how many IPs after this calculation? You will get 65,536 and into 16. These many number of IPs you will get in your class B. 10,48,576 IPs in total. How come? Just use the same method. 172.16.002 to 255, and after that 172.16.1.0 to 55, and so on 172 16.255.0 to 255. That will give you 65,536. After that, 172.1700, you'll run with this whole thing again, 65,536. 172.18, and at last 172.31.00 to 255, 172.31.1.0 to 55, and then 172.31.255.0 to 255, which is 65,536. So what is the difference? What is the how many of these are 16? So 16 into 65,536, which is your total, these many number of items. Make sense? And when it comes to class C, it's pretty simple. I don't need to explain again. Class A is again a huge number, 10.0.0.0 to 10.255.255.255. Okay, so that means it's very simple, 256, 256, 256. How come? First octet, second octet, complete third octet, right? That means 256 into 256 into 256. Make sense? This is the whole range. How much? I think 1,67,77,216. That is the whole class C number of IPs. Now, how you will break down into 1500 IPs? I just need a 1500 IPs, or maybe let's say if this floor is expanding and I'm providing 2 IPs to each person. One is over the Wi-Fi. Even if they're carrying their mobile, I'll give the free Wi-Fi to the people who are working in office. So 1500 people into 2 IPs. Currently, I need 3000 IPs plus future ready 50%, another 3000 IPs. Total 6000 IPs I need. That's a requirement for this floor. So I'm using class B. Okay, fine. I'm using class B for this. Why? Because it's a small mid-range organization. If I want to expand, if I'm trying to buy another office in another city, I want to use the same range. One thumb rule is never ever duplicate your IPs. Duplicate IPs won't accept it, right? So how I will plan? Total number of segregation department segregations, 7 departments. Okay, and for each department I'll give 256. How? Let's see. For VIP 172.16.250.0 to, it's random, 250 172.16.250.255, which is total 256 IPs. Okay, allocated to This is for these people. I'll call it as /24. I'll explain what is this /24 later on. But for now, consider /24. Right. Now, for other department, let's say HR 172.16.1.0 to 255, which is 172.16.1.0/24. Now, is there any conflict between these two? No, both are unique. Correct? So for locality 172.16.2.0/24. For these IT people, this is the range. And for developers, 172.16.3.0/24. Another development team, 172.16.4.0 or maybe 3.0/23. I'll tell you what is that. 3.0/23.
So it is randomly allocated, or is there any reason like why one dot is allocated to HR, something like that?
I want to uniquely allocate for each and every department a unique range, right?
Okay.
So I'm dividing them into a 250 chunks.
Okay.
Okay. So when I want to divide them into 256 IP chunks, I have to select the second octet unique, because the last octet is having 256 IPs. So if I keep on rotating the second octet, you will get a new IPs.
Okay.
Correct?
Yeah.
16.5.0/20. And in the reception, again, people will use 172.16.100.0/24, which is again unique. And for VPN device also, and for other security and other stuff, 172.16.0.0/24, the starting range. So if you consider 0, 1, 2, 3, 4, both are useless here. 5, 1, 2, 3, 4, 5 up to 5, and then 250 is randomly used here. 100 is randomly used for reception. Okay. Now I do have a security cameras and other security devices. For them, I'll say 172.16.101.0/24, which is 100 for reception, 101 for your security cameras and other equipment. And also, I'm saying I'm going to offer free Wi-Fi to the people in this office. I have a Wi-Fi booster is set here. Booster is set here within the floor. All the Wi-Fi routers will be configured except this VIP with 172.16.150.0/ we'll say 20. 150/20. Now the VIP security, it's pretty simple. 172.16.251.0/24. Okay. VIP users are connecting to a cable, they'll get 250. Connecting to Wi-Fi, they'll get 251 IP range. So this is dedicated to your senior management team who sits in the office. Now, how this has been segregated like this? Okay, why I mentioned /24, why I mentioned /23, why I have mentioned /20, and why I've mentioned everything everywhere it is /24. How this is defined, let's understand. Right? Please recollect the discussion point. the first discussion point I meant to say. Sorry, my bad. Octet 1, 2, 3. Right. So 8 plus 8 plus 8. How much? Slash 24. Right. So let me go to here. I'll consider 172.16.0.0/24. That means this range starts from one. When I say /24, this is /24 is subnet mask. Okay, so what I am masking here, I am masking these three. 24 means 8, 8, 8. All the three I'm masking. That means when I say masking all the three, these three will become a static. It will not change. Make sense? Clear? So when I'm masking this, what happens? Your IP starts from 172.16.0.0 and 1, 2, 3, and so on, 4, and so on up to 255. In total, you will get how many IPs? 256 IPs you will get. But I said you can use only 254 IPs in on-premise. 0 and 255 are taken out. Okay. Plus, when it comes to cloud, whether it is AWS or Azure or GCP, IP 1, 2, 3 is taken out for cloud internal usage. Okay. In short, if you are allocating this range, this is the range of IPs you will get. Out of that, you will lose 5 IPs, 0, 1, 2, 3, and 255. How many IPs that you will get total? 251 IPs for customer usage. Okay, so if I'm talking about this office, you will get 254 IPs. 254 IPs. If I'm talking about cloud, you need to minus 3 more. That is talking about your /24. So same thing applicable for HR as well. 172.16.1.0/24. 256 IPs, usable 254. 172.16.2.0/24. This is for local IT. Again, you will get 256 IPs, usable 254. Now, when it comes to 172.16.3.0/23, okay, I have two rows, or let's say 2 cubicles where people are dedicatedly working in development area. Right, I have more than 500 people here. So 256 IPs I can't survive. I need at least 500 to 1000 IPs. So how this subnetting works, as I said, if I say /24, these 3 octets will be static. This is freezed. Now, if I keep on increasing it, you will lose the IP. This number, a subnet mask number. If I keep on decreasing it, you will get the IPs. How that works? Let me. Oh, fine. How that works? Let me explain in a different way. So If I'm using 172.16.00/25, okay, this is this when I use 24, this is the output. If I use 25, what happens? You need to divide it by 2. 256 divided by 2 is 128. So give me a second. Your IP range starts from 172.16.0.0 to 126 or 127, in fact. 0 to 127, that's the last. Okay, so traditional way, you'll get 126 IPs usable, and in cloud, 123 IPs usable. You need to minus 5 IPs in cloud. You need to minus 2 IPs in on-premise. Okay, let's increase this by one number. Then this will become 64 IPs divided by half /27. Then this will become 32 IPs. 16.0.0/28. Then this will become 16 IPs. 29. This will become 8 IPs. 172.16.0.0/30. Your boundary become 4 servers. 172.16.0.0/31. Your boundary become 2 servers, 2 IPs. And the last one is 172.16.0.0/32 is only your IP. Your IP is /32. Make sense? If you keep on increasing the subnet value, you will lose the number of IPs. Now you keep on increasing the subnet, decreasing the subnet value. 172.16.0.0/23. 512 is the number of IPs. Right? Earlier it is 256. After increasing it, it will become 512. Okay, now if I keep on increasing it, 172.16.0.0/22, then this will become 1024 IPs. Make sense? 172.16.0.0/21, this will become 2048 IPs. 172.16.0.0/20, this will become 4096 IPs. Now let's go back to here. 172.16.0/20 means all the Wi-Fi users, all the 3 Wi-Fi users will get 4000 range of IPs. Okay, even though in future, if this office is scaled up to 4000 people, Wi-Fi settings no need to be modified because it is already pre-allocated. Getting my point? Right? So 4000 IPs. How many octets that you need to put in here? If I am talking about Wi-Fi, how many ranges that I need to consider here? So 172.16.150.0. Here you'll get 256. 172.16.151.0. 256. Okay, and up to how many? 8000, sorry, 4000. So 150, 151, 152, 153. Up to 153, you will get 1000 IPs. So 4 4s are 16. So 16 means you have to go up to like this 172.16.165.0/20. 0, which is again 256. So your Wi-Fi IP ranges will become between 150.0 to 165.256. That's the last IP in this boundary. Getting my point? So the third update will increase, and you need to accumulate all of them to make it 4096. So your range is from 150, 151, 152, 153 up to 165. So this will become your 4096 IPs. Similar case here. Okay, similar case here. Now, if I want more IPs, more IPs, 172.16.00/19, that will become 8000 plus IPs. So I'm leaving that above overhead values, right? So 8000 IPs. 172.16.00/18 will become 16,000 IPs. I'm again leaving that overhead numbers. 172.16.00/17 become 32,000 IPs. One last range, which is 172.16.00/16 become 65,536 IPs. Okay, so when I say /16, the last two octets will become static, and these two octets will become dynamic. So /16 mask these two, /24 mask all the three, and in between you keep on playing. Right? If you need a more IPs, increase it, decrease the number, subnet number. If you need a less IPs, increase the subnet number. I would say treat /24 is always as a base to define the IP ranges, so that you will be able to judge it whether you need a more IPs or you need a less IPs. Okay, so considering this, how many IPs that I need to allocate to my office? 1, 2, 3, 4, 5, 6, 7, 8, 9,000. Sorry, 9 into 256. Around 2,250 or 2,300 odd IPs I've allocated, and plus 4,000 Wi-Fi IPs. So 4,000 plus 2,000, how many number of IPs? Roughly around 6,500 or 6,200 or something. Okay, 6.5. Let's say 6,500 IPs that we allocated. How many total IPs you will get for this office? How many total number of IPs you will get? Very simple. Let me consider, for this is one of the office in India. Okay, India office 172.16.0.0/16. Total you will get 65,536. Out of 65,000, you have taken, let's say, all IPs for this office. Fine. Now you're growing as an organization. You want to increase, or you want to open a new office in you want to increase a new office in India only. right? And I need a IP ranges. So how we will decide? Very simple. 172.17.0.0/16, that will become again 65,536 IPs for your new office, and no conflict, because on the other office I'm using 172.16, in this office I'm using 172.17, no conflict at all. Okay, I'm planning to use or build another office in UK. Just an example, UK office. This, then I will say 172.18.0.0/16. Again, this will become a unique. So how many such offices that you can open? If you are using class B, you can open total 16 offices like this. So each and every office will get a unique range, and you will be able to manage your 16 offices together and as a single private organization. Right now we are growing. Sorry, class B won't help you. You need to use class A. Can class A and class B communicate together? Yes, you will be able to exchange the data between class A and class B and class C, class C and class A. There is no restriction in that. I'm purely talking about private IPs. I'm not talking about public IPs at all. Right? Am I clear on this point? Any questions on this so far? Whatever the things what we discussed?
It's clear.
Satish, Wasim, I think, Wasim, this is something we haven't discussed in detail in the last session, I believe.
Yeah, like this was a little bit more in detail.
Right. So I hope this will give you some insight on how we will plan the networking for on-premise.
Yes. Yeah.
Because this is our base, we'll adopt the same on our AWS.
Sure.
Okay, so tomorrow's session, what we will do, we'll still have some more basics that we're going to discuss related to AWS. Okay, this is more of a on-premise, or let's say your local office basics, networking basics. Tomorrow, what we will do, we'll try and discuss AWS basics, what things we need to make sure, like how we start your AWS journey and all that we will discuss tomorrow, and then we will take it from there. So we have classes on Saturday. In case if you are available, let's do it on Sunday as well, so that if I occupied on weekdays somewhere, I can take one break on weekdays itself rather than taking a week off on Sunday. You guys fine with that?
Yeah, Srinivas.
Yeah.
Sunday I'm not sure because I think I'll go to church and have all the Sunday some other timing like evening or something.
Yeah, we can do a flexible time. It's not an issue.
Okay. Then
Okay, that we will discuss on Saturday on what is everyone's availability on Sunday. Accordingly, we can connect.
yeah,
Sure.
Right, then I'll stop here, and what I'll do is I'll upload both the videos. So please ping me your email IDs once again, because I have them on somewhere in the notepad, but if you can ping me on WhatsApp, I'll be able to share these two recordings with you all.
Okay.
Right then, so I'll stop here. I'll see you tomorrow same time. Okay,
Sure.
ping me on WhatsApp, please. If I close this chat, it will disappear. So
okay, sure.
Yeah, sure.
yeah, thank you all. See you tomorrow. Bye-bye.
Thank you, Srinivas.
Thanks,
Thank
Srinivas.